Hi, welcome back to the Introduction to Python Programming course. This is Section 8, Dictionaries and Sets. The lesson objectives for this video include understanding the following: dictionaries, key value pairs, sets, frozen sets, and that last bullet is the commit related to getting the resources out of the version control project. And of course, we'll use that when we get to the lab part of the lesson. Dictionaries, they are similar to lists. Dictionaries are also known as associative arrays, hashes, or hash maps. And depending on the term is going to depend on which language you're using sometimes. We can use empty curly brackets to create a dictionary. And then of course we can use the key value pairs, which is the big thing for dictionaries, is that they are key value pairs. On line 2 in the screenshot, we can see that we're creating a dictionary with the curly brackets, and we have two different types of key value pairs. We have a first name with a value and a last name with a value. And then on line 9, we print out A with the square brackets and a call to which key we want, and we put first name. And what you would expect is what happens is that John would print out. And the other thing about dictionaries is that they are immutable and unique. So mutable means that we can change the values of those key value pairs without creating new data objects. Dictionary keys must also be unique. You cannot have multiple entries with the same key. So for example, at line 2, if it was first name had a value of John and last name had let me restart that. If first name had a value of John and then we did a comma and then we put first name again and said it had a value of Smith, what should line 9 print out then when we call the first name key? Well, that code would still run, but what would happen is that the last entry would overwrite the first entry. So it would print out Smith because it was the last time we entered the value of that key, which was first name. So remember that the key has to be unique. Sets and frozen sets. So set theory is from math. I think if I remember my math correctly, I recall going over it in middle school. What sets are useful for comparing different sets of data, as one might imagine. And on the screenshot, we have a basic rundown of set theory, which is the union of sets, intersection of sets, symmetric difference of sets, and complement of sets. So when might you use a set in a real world use? Well, maybe you have a set of social security numbers from two databases and you want to know who exists in both. Well, that would be an intersection of sets, which would consist of the common elements in sets A and B. So that's a quick real world use case in case you're wondering, hey, when would I use this set theory? Well, there's an example. So sets are dictionaries without the value keys. Keys must be unique again. So we can't have that social security number in that list with the same one multiple times. So when creating sets, you can see that they can look similar to dictionaries because we can use the curly brackets again. Of course, we can use the set function to create a set as well. And then a frozen set. Frozen set is very easy. It's a set that is immutable. So when would you use a frozen set? Again, you would use a frozen set when you're creating a set of items that are not going to change. If you are going to change those items, you're going to want to use a regular set, which would be mutable. So let's go ahead and jump into the lab environment and take a quick look at the resources related to this lesson. All right, here we are in the lab environment. I'm going to go ahead and right click in my directory, git bash here. I'm going to go ahead and do a git reset hard just in case I change something on accident. And throw those changes away, otherwise git will complain. And then I'm going to check out the next commit, which is 053 E16. Okay, that's section 8. We're going to go into that directory, take a quick look at the cheat sheet. Okay, so again, additional information to look over. Let's take a quick look at the examples. We only have one example. Let's go ahead and run this. All right, what is this question at the end? What prints out and why? Looks like Joe printed out. Okay, so what's the question? We printed out A, but you can look here on line 21. We made a call to C, when we changed the name to Joe. So it would appear that changing the list C, or no, the dictionary C, caused a change to the dictionary A. Now, right off the bat, just looking at this, now we need to look at more, but right now it looks like what we're going to have is two variables pointing to the same data object. And we can see that's the case because we had C equal to A. So that turned into two variables pointing to the same data object. And then when we made a change to that data object, it would appear that, you know, both variables were affected, but in reality, the variable is just a label. So the variables just point to the same data object. So when we change that one data object, then it appears to change for the other variable, which it did because they point to the same data object. All right. Let's go back. Let's take a look at the exercises and open up the questions. Task 1, what is the major difference between a dictionary and a list? That's from the lesson. What is the potential problem seen in the code below? All right, I think I discussed this already. That's a good question though. And task 3, create two sets, A and B, loop through and print both set values if A have an intersection value of B. Okay, so that sounds a little weird because the variables are just single letters. So it says loop through and print both set values if A, should say has, if A has an intersection value of B. Okay. All right, those are the questions. Pause the video if you want to take a stab at all those questions because we are about to go over them in 3, 2, 1, let's go. All right, so here are the answers. I'm going to open up the answers. Should have left the questions open, but I'll go open them up again for reference if I need to. A dictionary uses a key value pair. That's true. This allows the programmer to associate a keyword with a value. For example, person height equals 72. Yeah, that's a good example. All right. So hopefully you got that answer to that question or something very similar. I, of course, wouldn't expect you to get the exact same wording. Task 2 answer. The code reference attempts to assign two distinct values to the same key. The first assignment will be lost or overwritten. All right. So let's just open that question up again to be sure that's what it looks like. So we have the two keys that are the same, which is the first name. So this Sam overwrites John when this object is created. That's because we need unique keys. The unique key can have, you know, one value associated with it. And then task 3 answer. So we got A being equal to a set, B being equal to a set. So it looks like we could be creating a dictionary. The big difference there is that we don't have a key value pair. We just have a value. All right. So then we say if A dot intersection, which is a function that you can use with sets, B, then we loop through and print them out. That was the question, right? Create two sets, loop through and print both set values if A has an intersection value of B. So let's see, for I in A union B, print I. Oh, so what I did here is I did a union, which prints out all the values, or which would combine all the values from the two different sets. If we go back and we look at that example of a union in the slideshow. So that's why I didn't have to create two forward loops to go through A and B. Okay, I hope you got those. Let's go ahead and jump back into the slideshow and finish this lesson out. All right, here we are. And just a reference to that one question, you can see that a union of sets consists of all elements in set A and B. So when I used the union, I was able to get access to all the values in those sets and print them out to answer that question. Okay, outside of that, we've talked about this slide. Let's go ahead and head to the next one. And it's the section conclusion. In this lesson, we learned about the following: sets and frozen sets. A set is a list of items. It's like a dictionary without the key. It's just the values. Then sets are mutable. A frozen set is a special set that is immutable. So you would only make a frozen set if you had no need to ever change the values once they were created. If you needed to change the values, you would want to use a regular set, which is mutable. Then we also talked about dictionaries and key value pairs. So that completes this lesson. I hope you enjoyed it, and I hope to see you in the next. Thank you.